So another way that we can figure out a percentage of values between values is what's known as the empirical rule. And there's 3 parts to it. And so here's what those are. For any normal distribution, normal curve, number 1, about 68% of the values are within 1 standard deviation of the mean. About 68% of the values are within 1 standard deviation of the mean. Now, again, there's our, whoops, the little phrase there, within 1 standard deviation of the mean. So let me kind of draw up a picture here of that. So we've got a bell-shaped curve. We know that the mean is right in the middle. And so this within 1 standard deviation, what that means is, if I go out, so the standard deviation, usually we indicate that with an S. So if I add a standard deviation to my mean, x bar plus an S, plus a standard deviation. Now within 1 doesn't just mean 1 above, you could also go below. So if I subtract a standard deviation from the mean, you know what I'm saying there? What we're talking about is this area right in here. From this, whatever it is, to this one. What this is saying is, that's 68% right there. 68% of the values are in there. And that again goes to the fact, most of them are in the middle, right? That's 68%. That's over half of the values are within that range right there. Okay? So yeah, most of them are in the middle. Again, what we're saying, that's by the normal empirical rule, we can say that's 68%. Okay? Let me go ahead and give you the other percentage and we'll talk about some other things, all right? Number 2, all right, so the empirical rule, we just keep adding standard deviations. About 95% are within 2 standard deviations of the mean. So, if we extend it out, instead of going 1, we go 2 each way. So here's our mean. So if I go 1 and then a second one, and then 1, 2 back, that's going to capture, percentage-wise, 95% right there. So 95%, that doesn't leave a whole lot not in there, right? And then the third one is about 99.7% are within 3 standard deviations of the mean. Well, 99.7%, that's just about 100%, so it doesn't leave a whole lot on the edges there, so kind of make a diagram here. So if I go 1 standard deviation, 2, 3 standard deviations out, and then 1, 2, 3 back. In between this one and this one, you got 90, all but 0.3% of them. Right in there. Okay? So that's the percentages we'd like you to know for these empirical rules. Now, not only that, but here's another thing to note. Because of symmetry, and the way I look at them, the way I look at these problems is, a lot of times we're not wanting to go both directions, 1 below to 1 above. A lot of times, we may need to look at this. How many would you say? All right, so for this first one, I got the mean. All right, so if I just went to one standard deviation above, and then I go from the mean just to that, what percentage would you say that is? Symmetrical. So this is 68.
34.
It's half of 68, isn't it? Yeah, this is half of 68. So in practice, in these problems, a lot of times what you're dealing with is you're dealing with half of each one of these. So, but this is kind of the way you typically memorize it or remember it. But in practice, a lot of times we're just halving these numbers. We can do the same for each one of these, okay? With me. So if I did the same thing, X bar to this one, that would be half of the 95. And I could go the other way. If I went from here, say the mean out to this one in this range, it'd be half of the 99.7, right? So sometimes you do the half ones, okay? All right, but those are the three to remember. All right. So yeah, let's try one. All right. Okay, so the times to run a lap at a track are normally distributed with a mean of 72 seconds and standard deviation 4 seconds. Number one. What percentage of times are between 68 and 76 seconds? So we're just looking at, all right, so we want to know what percentage values are between 68 and 76. Now, what I would like for you to do on these is, picture sometimes is worth a lot, helps. And so I'd like for you to at least draw that out. That'll give you at least some points here. Draw this picture out, all right? So it's a normal distribution, okay? So that's a bell-shaped curve. And so here I want between 68 and 76. However, to know where those times would be located, we need to start in the middle here. And what number is in the middle? How do I know what number's in the middle? What always goes in the middle? The mean, yeah. The mean goes right in the middle. So in this case, right in the middle is 72 because that's the mean. Okay? So 68 would be to the left here, and then 76 is to the right of that. Okay? And so I'm talking about this percentage right here. Right? Now, I didn't state it here, but on these, I want us to use the empirical rule. We'll talk about another way to do it in a second or two, but we're going to use the empirical rule for this. For these problems we're doing now. So when we're using the empirical rule, it's 68%, percentage are 68, 95, and 99.7. Those are the three, usually the way we remember it. And so how do we know which one to use? Well, 68 is within one standard deviation of the mean. 95 is within 2 standard deviations, and then 97 is within 3. So what I'm getting at is here, the empirical rule, that's based upon your number of standard deviations away. And so what you need to figure out is, all right, so how many is 68 away, standard deviations away from the mean? So I'll write that question out here. How many standard deviations is 68 from the mean? Well, a standard deviation is 4 seconds, right? And so 68 is 1 below, right? That would be 1 below the mean. What about 76? Well, 76 is 1 standard deviation above the mean, right? Because standard deviation is 4. So I'd add 4, I'd add 1 4, in other words, 1 standard deviation. So that's 1 standard deviation above. So, which percentage am I talking about?
68.
I'm talking about the 68, yeah. Both of them are within 1, so both of them we're talking about the 68%. So in this case, yeah, it's within 1. So because I've gone 1 below to 1 above, so that's 68%. Okay, so that's kind of one thought process you can go through. All right. Number 2.
So would that be your answer then?
Yeah, that's the answer. 68%, so that percentage is 68% based on that empirical rule. Yep. So that started off kind of good. Now, like I said, here's what can go on. All right, so what percentage are between let's go 64 and 80. What percentage are between 64 and 84? Okay. Again, let's at least draw the picture here. Nothing else. Draw a nice little picture. All right, so we've still got the mean of 72. So again, we're dealing with one on the left, one on the right, because 64 would be down here. It's pretty good ways from 72. And then 84 is above, and that's pretty good ways out there too. So I'm talking about the percentage from here to here. That's the percentage I want. Yeah, but in this particular case, all right, so again, using the empirical rule, we'll do it another way in a second, but if I use this empirical rule, I need to figure out, the empirical rule is based on these standard deviations away. How many is 64 away from 72? How many standard deviations? So a standard deviation is 4. So if I go 1 standard deviation, I'm at 68. 64 would be 2 standard deviations below. Because I'd have to go 2 4s, right? So that's 2 standard deviations below. On the other hand, 84, is it 2? No, because to get to 84 from 72, you go to 76, and then 80, and then 84. See, I'm just stepping by 4 because that's the standard deviation, right? So it's 3. But it's 3 above. Uh-oh, that's what I'm saying. A lot of times you'll get kind of a mixture of the empirical rules percentages here because, yeah, the 2 standard deviations, we're talking about 95%. The 3 standard deviations, that's the 99.7. So how do we, well, like I said, sometimes we have to half those percentages. What would this percentage right here from the mean to the 64 be? Because I'm talking 2 standard deviations below, so I'm talking the 95%, but I'm only talking half of it. It's half of 95% here. Yes? On the other side, I'm 3 standard deviations above, which is the 99.7, but I'm only going from the mean to above 3 above. So what percentage is that? Well, that's half of the 99.7%. This is 47.5%, and this would be 49.85%? So if you kind of understand what you're finding with these, it's very helpful, okay, especially when we get to the next ones here. But all right, so what percentage are between? Well, I've got 47.5% on this side. I've got 49.85 on this side. So I've got a total of what? 97, is that 97.35? Is that right? And those two up?
Yeah.
7. So that's kind of the general procedure that we'll take on these, all right? Question or concern?